how you want to establish your orientation to mill the part. So you have your X, Y, Z, the three linear axes. So you want to establish how the part is going to be positioned to be placed on the CNC for milling this part. So you have your X-axis, the Y, and then the Z. So currently you have the length, the longer edge of the part parallel to the Y-axis and the shorter side parallel to the X-axis. If that's the way you want to leave it, you don't need to change the orientation from which you're milling the part. For example, if you have a need to mill the part from the bottom side, you would just have to flip the coordinates in here where you can say you want to rotate it on the X by 180 degrees. You'll now notice that the Z-axis is being normal to the bottom face of the part.
Okay.
So you don't have to go back and remodel the part or redefine the planes that you're creating from your reference planes. You could just go back and orient the coordinate system under the machine tool setup. You have machine tool coordinate system. Now for this particular part, since you already have the orientation set correctly, I'm not going to change. I'm going to say leave it at the world coordinate system, so it'll automatically inherit the same orientation as you have in the world coordinate system for the machining coordinates as well.
Okay.
Any questions so far?
Well, just one question at the beginning. How did you get the Visual Cam 2017 tab on the SolidWorks? Did you just add it as an add-on software for it?
Absolutely. So once you install Visual Cam 2017, it'll show up as an add-on, and you will see it under Tools. If you go down to Add-ons or Add-ins in SolidWorks, once it's installed, it'll automatically show up right in here.
Okay. All right.
And it's automatically set to active and also startup when the application loads up.
Okay.
And it'll automatically load the plugin when you open a part. So if you open up a drawing or an assembly, it's not going to show the plugin. If you convert it to a part and open it in a part, it'll show up for you automatically.
Okay.
Okay, so we got this part in here. The next step is to define the machining process, whether you're going to be doing 2, 3, 4, or 5 axis. So for 2 and 3 axis, you leave it as 3 axis. And that's automatically the default choice in standard. In the next step, we could select the post processor. This would be the machine tool that you're going to be outputting the code for. And I believe you're working with CNC Masters, right?
Correct.
You can output the code in inches, or you can do millimeters. I'm going to do inch output and specify the output file extension as .nc, then accept it. So this information is automatically updated under machining job. In the next step, you would want to define your workpiece. So you go down to stock, and then choose a type of stock. With the standard, you could do a box or a cylinder stock. The additional types are offered in the Pro configuration. So if you choose box stock, the system will automatically compute the minimum extents that you need to be able to mill this part. So it says 3 by 6, and the height or the thickness is 1/4 of an inch. Now if you want to start with a slightly larger piece of material in here, you can specify an offset. You can either enter in the dimensions, or you could go back and define a stock as a part box stock, and you could say you want it to be 50 thousandths larger in X, 50 thousandths larger in Y, and if you want to add a Z stock, you can specify it as well. So in this particular step, it'll add 50 thousandths around the part, so you don't leave a factory edge around the part. Or if you already have the stock squared to the size, you could go back and set the stock offset to be 0, so it'll be right to the edge of the part.
Okay.
Would there be any questions so far?
No, looks good.
All right. In the next step, we would want to establish where you want to place your origin. So when you place this piece of material on your CNC equipment, you probably want to zero it out to one of these corners of the workpiece. So we do that by going into Work Zero. We could pick Set to Stock. You could choose High as Z for the top face or Low as Z for the bottom face. And then you can pick what corner you want to place the origin, the southwest, south, southeast. So all your coordinates will be interpreted based off this origin. Am I making sense, sir?
Yes, very
Now, if
good.
you want to leave it at the origin where it is, that's where by default it's going to be, which is going to be 0, 0, 0. But here you can see that it is shifted by 1/4 of an inch. So your 0, 0, 0 is now being set to this upper left corner, the top and the southwest corner.
Okay.
Okay? Now, once you have the Work Zero define, this is your program, so all your toolpath coordinates will be interpreted based off this, which means when we do a pocket operation, your cutting would be in a negative Z and the retract to clearance would be positive Z, since the Z0 is set to the top of the part of the stock material.
Okay.
So typically to program this part, you would want to use some end mills, you may have some drill, you may have some taps in here, right?
Correct.
So there's a couple of ways we could do it. I'm going to show you both the techniques. We have what is called feature detection and machining that we have introduced in version 2017, where we can actually identify features from the part. So when I go ahead and say select features, I can pick a face, and in this particular step it's actually going to identify the features. It says there's a planar face, you have a prismatic slot, you have a pocket feature, and then you have these whole features that are being identified. You can see that they're identified automatically.
Okay.
So I could go through the process of programming it using feature detection. So right click on the face, planar face, and I can choose facing operation. I can grab a tool for it. So for example, if I want to use a face mill, I can create tools from my library. I can also define different types of tools. We have ball and mills, flat mill, corner radius tools for engraving, chamfer, taper, face mill. You can define tools under each of these tool types, specify your properties for the tool, feet and speeds, and this can be established based on the material you're working with, the tool material, and Visual Mill has a built-in calculator that can help you with establishing your feet and speeds. And all of this information can be saved into a library. So when you have a similar part that you like to program, you can just load them from a library. And then you got your cutting parameters. You want to cut what kind of cut pattern. You want to just do like a linear pattern, cutting back and forth. You can choose the direction or the angle of cut. You can specify like a step over in here. I can do a % tool diameter or distance or number of levels. I can also specify entry and exit, how you want the cutter to enter and leave the material. I can specify these parameters in here. For example, I can key in all the parameters as needed, and then also you can fit arcs to your toolpaths, and you hit generate, and there's your facing toolpath right there. And if you want to make any edits, you always double click on it. You can go back and make a change to the operation and then pick generate. So now the facing operation is programmed. So I'm going to add a little bit thickness to the stock in here, so at least you can see the material being removed, right? I'll put in like 10 thou stock above it. So now when I go ahead and run a verification, you'll notice that it's removing that stock above it.
Okay.
Do you see it, sir?
Yes, very good.
Yep. So there's the facing operation. The next step is you want to go ahead and pocket this feature in here. So if you actually take a look at this feature, you have a radius of 1/4 inch, right?
Correct.
So if you use a 1/2 inch end mill, you can mill that slot. So we have a slot machining operation. Right click and I can choose slotting, and I can grab a tool, 1/2 inch end mill, and you can specify the parameters for the slot, like whether you want to go natural or reverse direction, climb or conventional. You can add a cleanup pass. You can also choose the depth per cut. So it automatically determines the depth. Since we're doing a feature detection in here, it knows the depth is a 1/4 inch, but I can break it up into multiple passes. I could say I only want to go in 50,000 passes and alternate between the cut levels. So in this particular step, it's doing it in multiple steps as you see it.
Okay.
Now if I want to use a smaller cutter, it'll do a tricaudal cut pattern. If I switch the tool from a 1/2 inch to a 1/4 inch, regenerate it, you'll see that the cut pattern does a tricaudal, or we call it a high-speed cut pattern.
Okay.
In some systems could call it like an adaptive cut pattern. So this is a high-speed cut pattern as you see it right there.
Okay.
Would there be any questions so far?
No. Oh, looks good.
Okay, so we got the pocket operation in here, the slot operation. So the next step is to do the pockets. I can right click and choose pocketing, and with the same feature selected, with the same tool selected, I can go ahead and enter in the parameters. For example, I could leave some stock in here, like a 10 thou stock, and go back and add a profile pass to clean it up. I can choose my cut direction. I can specify the cutting parameters. We also have offset, linear, and high-speed cut patterns. There's your depth per cut. I could put in like 50 thousandths. Entry and exit can be set right in here. You can also do true arc fitting and then generate. So there's the pocket toolpath for these features. So I didn't have to do any picking of features or geometries. We were able to identify from these on the model itself directly.
Okay.
Now, if I want to go back and do like a profile pass to clean it up, I can right-click on the same feature and choose profiling. And the feature is selected, grab the same tool, and I can specify to climb cut, and I can go to the finish depth in one pass, and I can also apply entry and exit in here, and I can specify whether you want to do like a radial entry and exit, or if you want to do a linear entry at an angle, you can choose that. You have all the controls in here, and then generate it. So there's your finish pass. It's doing an entry, radial entry and exit, following the profile to clean out the material that was being left from the previous step.
Okay.
And finally, we want to work on these holes in here. So we have these holes right here that are 150 thousandths, and then you have these that are basically you have a tapped hole in there, right? So that's diameter is 0.201. So what you can do is you can right-click on these holes and then do a drill operation. So if you have a 150,000 drill, you can do that, or you can do a 1/8-inch bit. You want to do a hole profiling, you can do a hole profiling. Do you typically have a tool that fits the size of the hole?
Typically, yes. Yep.
Okay, so I'm going to do a drill operation on that, and you can see that it automatically has the information about the diameter and the hole properties in here. I can specify a tool. I'm going to create a tool that would be 0.150. So I can specify if it's a specific number in here. You can specify the tool number, like the drill size number. I'll set these in here, save this up as a new tool. And I can specify the cutting parameters. You can see all the depth is set. You can say add the tooltip to drill depth. And if you want to go in multiple steps in here, you can do a peck drilling as opposed to just a standard drill. A deep drill is basically a peck drill, and you can specify the step increment. And you can also sort them by a minimum distance in here, so it'll minimize the transfers. So now when you run a verification, you'll notice that it did automatically go all the way through, and you can slow down the simulation to watch it. So it's doing a peck drill operation. Now with the same tool, we could do a drilling on these features as well, right?
Yes.
Because these holes that you have here, if I take a look at the hole properties and do a drill, the diameter is 0.201. So you probably want to drill first and then do a tap. Is that right?
Correct. Correct.
Okay.
Yes.
So you could use the same tool that you use for the drilling of these through holes to drill these holes as well. You can just edit the operation in here. You can also add this hole feature to it and then generate. So that'll basically take care of drilling all of those with the same tool, unless you wanted to use a larger tool for these.
Okay.
And the next step is you want to do a tap. You just right-click on it and then pick a tap operation. You have the whole feature selected. You would want to define your tapping tool. So would that be, do you have the tap size for it in the pitch?
It's a 1/4-20.
Okay, so that would be a 1/4-20 is 20 threads per inch is 50 thousandths, right? The pitch?
Correct.
So you specify the tool properties in here, and you can compute, the system can compute the feed rates based on the RPM and then the pitch. So if you put in 500 times 50 thousandths, you get a feed rate of 25. Or if you slow it down here to 200, that'll be 10 inches per minute. So we can compute it automatically based on what you specify with the thread pitch and the speed. And then you go into feeds and speeds. That information is updated in here, and the computation is done at the posted level, post-processing. You can choose a tap operation in here and generate it. So now when you post this out to the machine, right-click and post, you'll notice that the feed rate is computed in the posted code. So we can do a tap cycle as well. So you can, now once you have all the operations programmed, when you run a simulation, you'll see that it basically shows as a drill operation for the tap as well. And then you can finally do a post process, right-click and do a post. And there's your posted output file for all the operations put together.
Huh.
Now the code program is now ready to be transferred out to the machine.
Interesting.
Yep, and saving the file, or you can do a save or save as. Saving it in SOLIDWORKS will automatically save all of the machining information that you programmed to the same file.
Okay.
So this is how you can use feature detection in machining. Now if you do not want to use feature detection, manually program it, you could select edges in here. So you could say I want to do a pocket machining. I can go select curve edge regions. I can right click and do a select loop or select tangency right there. Pick the chain and specify a tool for it. And I can specify the cutting parameters. So that's how you can do manual selection and programming. And it's very intuitive, as you can see right there. You can control the parameters like depth per cut and generate the toolpath.
Okay.
And if you want to delete an operation, right-click and cut will delete it. Now, once you have all of these operations programmed, you could also save these out to a knowledge base. What this allows you to do is, if you have family of parts or parts similar to these that you're programming, you can load the knowledge base and associate the features to it, so you don't have to go through the process of establishing the entire workflow in here.
Okay.
And that's a very nice feature that's offered to you in the standard configuration. Do you have any questions so far, sir?
No, it's very, very interesting. Very interesting. I think I see what you're doing there. I'm just kind of curious, it's kind of more of a side issue. If you did not have the solid model, if you only had like a two-dimensional drawing, how do you generate the same kind of things?
I can definitely help you out here. So let me go ahead and pull this drawing in here, right? So you have the drawing right there, right? I'll just take the DWG. I'm going to pull it in here. And I'm going to be asked, do you want to create a drawing or I want to create a part? So I want to import to a new part. That's what I'm going to pick. Okay. And then I'm going to click next. And here it'll ask, what do you want to import? I'll just pick all this information in here into inch units. Okay. And I'm going to hit finish. So this is going to import it as a sketch into the part. You see that, sir? Now, what I'm going to do here is delete this layout information, which is typically not necessary for producing or generating the toolpath, right? So I'm going to delete out what information is not necessary in here. And if you also want to leave the drawing where it is, you could, or if you want to move it to the origin, you could do that as well. So if you want to move it, so you're basically taking advantage of SOLIDWORKS tools in here. You could say move entities from point. You can say you want to move it to point right there.
Okay.
So just to keeping it simpler. So there's your drawing right there.
Okay.
And the same workflow. Now there aren't any feature detection because it's not a solid model, but we can still work with it. So the workflow is you define your stock. You specify the thickness, which would be 1/4 of an inch.
Okay.
So there is your stock material right there. You see that, sir?
Yeah.
And then I go through the same process, establish my work 0, and then I click on 2-axis. I could choose slot machining, and I can right-click and select the chain. And I can grab the tool for it. I can use a 1/2 inch or a 1/4 inch end mill and specify the depth for the slot. So in this case, since there is no solid model in here, you can specify a depth. You can say you want to do it in 2 passes. I'll put in 1/8 of an inch, generate. So there's the slot operation right there. And then I want to do a pocket operation, 2-axis pocket machining. Select this chain of geometries. Select the tool, specify the cutting conditions for it. You can specify the depth. You can enter in your depth per cut, any additional parameters that you like to put in, and generate. So the workflow would be similar. You want to do hole machining drilling, and I can either pick a point or I can just pick the geometry right here. I can select each of these geometries. As you can see, I'm just selecting those right there. And then specify a tool. I could have a, I forgot to save the tool to the library, the 150,000 drill, so I'm just going to go ahead and create a new tool in here. And I'm going to go ahead and specify the depth in here again, and then say add tooltip to drill depth. and apply a sorting sequence. And there's a drill operation. So you can see you can work with both solid models or just 2D drawings as well. So if I want to run a simulation for the entire process, right click and do a simulate until. It will give you a true representation of what you did.
Huh. All right.
And the same process for tapping as well. Now if you do want to turn this into a solid model, you can select the sketch in SOLIDWORKS and you can turn it into a solid model in here. You can do an extrude boss. You can do that as well. So you can just pick those faces right there and turn it into a solid model.
Okay.
So multiple ways to do it, right? You can use directly work with sketches. I forgot to set the depth in here. Yeah, I can establish the orientation in here. So you can turn it into a solid model, and you can also work with it by selecting the features, or you can just pick the sketch and work with it as well.
Okay.
And the power of our standard configuration is you can also do 3-axis machining, so you're not just limited to 2-axis. So I'm going to give you a couple of examples. Before I do that, I wanted to ask you, would you have any questions on programming this part, or any questions in 2D milling?
No. Very interesting. You've answered a lot of my questions about, how do you do something like this, and I guess you've answered most all the questions I have at this point.
Okay.
Very interesting.
Oh, thank you. So once you have these programmed, you just output the code to your machine. So right-click and post, and you can transfer to the CNC controller, the computer that drives your CNC machine. So you don't have to have SOLIDWORKS and Visual Mill installed on the computer that drives your machine. You just transfer the program out through a network, or if you have a, like a flash drive, USB drive that you use to transfer data, you can do that.
Okay.
So that's how you post the code, and then you can save this out or try it to a network shared drive, or you just transfer it across from an external drive.
Okay.
Would there be any questions?
No. Very interesting.
All right, great. So let me go ahead and pull in a couple of other files in here. We'll give you a run through of some of the other nice features that you probably would benefit out of.
Okay.
Do you do any 3D machining at all?
No. No.
Okay. All right, so I'm going to go ahead and pull in this part in here. This is basically like a cavity of a mold. Okay. And you can see there's a lot of sculpted surfaces, fillets, radiuses on the model. So for parts like these, you would need to use 3-axis machining. So the workflow here is very similar to what we did in 2D. We could define the machine tool. We could define the post processor. You build a stock material in here, so you specify the type of stock you would like to create, and there's going to be a rectangular stock. And then we go directly to 3-axis machining, and with the standard you get roughing, parallel finishing, horizontal, radial, and spiral. So I would want to start with the roughing process to hog up, as much as material as possible. And specify a tool. I'm going to pick a 1/2 inch end mill, set feeds and speeds and clearance, and I can also establish all the cutting conditions in here, like your step over distances. You can specify your cut patterns, all the parameters can be set, and then you pick generate. So in this process, it's automatically going to analyze the part, the stock, and figure out the areas where it needs to be roughed out. So there's your roughing toolpath in levels as you see it.
Okay.
So it's doing what is called a roughing in layers or roughing in levels, and it automatically clears the material out. So you don't even have to pick or select surfaces. And this is 3-axis. So you can see all 3 linear axes moving at the same time, and it's clearing out the material. In the next process, you want to go back and do a finishing. It could be a pre-finishing or a finishing. So I could start out with a finishing in levels called Z-level finishing, and I can contain the cutter just to stay inside this area. So I can do select loop or select tangency to pick a chain of edges, and then I go ahead and grab a tool for it, specify the parameters like the step over. You can also do an optimized machining to clean up the flats, and then pick generate. So in this process, it's going to do what is called finishing in levels. So it progressively steps down like a profile cut following the contour of the geometry. So that's your finishing, known as finishing in levels, Z-level finishing. It's also known as horizontal finishing. It's some systems call it finishing in level Z-level finishing or waterline finishing. And anytime during simulation, you can do pause and then pick simulate to end, which would run through the simulation process.
Okay.
Now all of these are also included in the standard, these methods that you're talking about here. Now we could go back and add another pass, what's called parallel finishing. This would be more like a planar finishing, where it runs in parallel passes following the 3D geometry. You can specify your step overs. You can change the direction of cut if necessary, and then pick generate. So this is ideal for areas that are not very steep, sculpted surfaces. You can see it's following the 3D model. You also have radial and spiral machining that are available in the standard. So you have roughing, parallel finishing, horizontal, radial, and spiral. So if I choose radial machining, I could actually pick a boundary in here. So I'm going to clear the loop selection. I'm just going to go pick this chain of edges around it here. Accept the selections in here. Use the same tool, and that's going to produce a radial machining toolpath.
Okay.
Or I could even do a spiral machining toolpath with the same set of boundary in here. Creates a spiral pass. So there's different techniques how you could program this. So you have starting from roughing all the way to T-slot machining in 2-axis. In 3-axis you have those 5 different methods, and you also have the whole machining: drill, tab bore, and reverse bore. All part of the standard configuration. Plus you have machining regions, features, and knowledge bases. Knowledge bases allows you to save the entire workflow of operations. So I can take these operations I programmed, I'm going to save this to a knowledge base in here. Now I programmed this on the cavity model, and I want to program the same on a core model. I'm going to show you how I can apply these toolpaths. Now when I want to ready to post process, I right click on post, I select my post processor, and in this case it happens to be the CNC Masters Inch. I'll pick that as the post processor in here from the list and post it out. So there's the posted code. Once it's processed, it's going to appear in a text editor right there. You could then transfer this out to your machine. So now when you save the entire workflow to a knowledge base, and I'm going to go ahead and pull in another part, which could be totally different from what this looks like, and we can still program it. So I'm going to use a core as an example first. I'm going to bring this part in, which is the core of the same part. And instead of having to program through the menu here, I'm just going to go ahead and click on load my knowledge base and grab this knowledge base as part cavity. You can see that the knowledge base is loaded, and I can insert a work 0 to establish where I wanted my 00 to be. So first I'll build a stock around it. I'm going to change the stock height or thickness, and I'm going to add a work 0 to set it to the top in the southwest corner. Now the roughing operation, all I'm going to do is right click and regenerate, and you'll notice that it automatically computes a toolpath. So it was loaded from the knowledge base. I can go back to the horizontal finishing. If I need to contain the toolpath, I can pick a loop around the part to specify what area I'm trying to contain it to. I can pick a boundary around the part, or I can just choose these edges around the part as well to contain it.
Okay.
And if you need to make any changes, any of the additional parameters, you can always go back and make those changes and then generate it. So while the toolpath is being computed, I can also add additional operations in here. Select that loop right there, generate the parallel finishing operation. So you can see that the horizontal finishing, parallel finishing, they've all been generated. So we were able to reuse the same operations that we established on the cavity mold to use it on the core mold. Right? So that's how we can effectively take advantage of knowledge bases to bring in your entire workflow of operations.
When you generated the 2 halves of the mold, so there was some function there that you could generate the thickness of the material you wanted, between the 2 halves of the mold?
That would have to be something you'd have to do in the design part in SOLIDWORKS.
Okay, gotcha.
Yeah, so you would basically do that offsetting in the design itself. Now, if you wanted to do it in the CAM, we have tools where we can shrink the part. If you want to shrink one of them, you can do it. So here you can specify what is called a negative stock offset in here. I can say I wanted to cut 10 thousandths into the part, so shrink the part overall by 10 thousandths. So that can do it in the toolpath itself.
Huh.
But
Okay.
ideally, you would want to do it in the design process when you create the two halves.
Sure.
So you have 2-axis, you have 3-axis, hole machining, drilling, all of these are included with the standard configuration. Now, let me go ahead and pull in one other file in here. Do you have any questions so far?
No, we're good.
Okay, so I'm going to show you how I can take advantage of the same knowledge base I programmed on this particular part. I'm going to bring in another part in here. And as you can see, this part is totally different from what you noticed on the other two files, right?
Right.
Okay, so I could still use the same knowledge base. I could say load my knowledge base, grab the knowledge base from here, and you can see that those operations are in there. You define your workpiece for this part. I can establish my stock height, and now I right-click and regenerate. The toolpath is being computed. So what it's loading from the knowledge base is your cutting conditions, like your step overs, your step downs, your tool, your feeds and speeds, all the cutting conditions. But the geometry could be different in here. So you could take advantage of your knowledge base to program a wide range of parts, like family of parts, or parts that are similar, or the parts that require the same workflow. You can apply those knowledge bases to it.
Okay.
So there's your roughing toolpath in levels.
Okay.
And here's your finishing toolpath. So it's running parallel to the y-axis. Since I set the angle of cut to be at 90 degrees, it's running parallel to y.